Today's lesson is 15-2, which is biased and unbiased samples. So first thing we're going to do is we're going to fill in this little bit of vocabulary in the paragraph. So it says here, the statistics is the practice of collecting and analyzing data. It can be used to gain information about a population or a group being studied. Okay, so population is a group that's being studied. So this is your vocabulary. Okay, that's a group being studied. A sample is often used instead of an entire population. Okay. A sample is part of a population and should be representative of the population. So this is what a sample. So a sample is part of a population. A statistic refers to a single measure of some attribute of the sample. So here, this is statistic. And that is a single measure of some attribute of the sample. Okay. Data from a sample are often collected in the form of a survey, which is a question or set of questions designed to gain information about the population as a whole. So this is a survey. So the survey asks a question or a set of questions. When choosing a sample from a population, it is important to use a valid sample method. Okay? This is one that is representative of the population. And, let's see, so when choosing a sample from a population, it is important to use a valid sample method. This is one that is representative of the population, selected at random, and it is large enough to provide accurate data. So let's write that in there. So this is representative of the population, selected at random, and has to be large enough to provide accurate data. Okay? So here are three different sampling methods. We have a simple random sample, we have a stratified random sample, and a systematic random sample. Okay? Now, for a simple random sample, each item or person in the population is as likely to be chosen as any other. Let's write that down. So each item or person in the population is as likely to be chosen as any other. In a stratified random sample, the population is divided into groups with similar traits that do not overlap. A simple random sample is then selected from each group. Okay? So in a stratified random sample, the population is divided into groups with similar traits that do not overlap. A simple random sample is then selected from each group. And then finally, we have a systematic random sample. The sample, in this one, the sample is selected from the population according to a specific item or time interval. So this is specific item or time interval. So now I have some examples tucked away here. I'm going to pull them out and we're going to decide, is it a simple random sample? Is it a stratified random sample? Or is it a systematic random sample? Okay? So the first one I have here says, to determine whether a candidate for governor is popular, a computer-generated random sample of 1,000 voters is surveyed. So we want to know, is this simple, stratified, or systematic? Good. That one is a simple random sample. So we're just going to put that in that column. Okay? Now, let's grab another one. This one says, a principal of a high school wants to use a survey to decide on the theme for their winter formal dance. She separates the students by grades 9 through 12, then takes a sample of the 50 students from each grade. Is that going to be simple, stratified, or systematic? That one is stratified because, again, they're split into groups, 9th, 10th, and 11th and 12th grade, and then a simple random sample is taken from each of those grades. So that's why that is a stratified random sample, okay? So let me grab another one. Okay, a state education department wants to measure the effectiveness of a new arts curriculum. So they divide schools in the state into 3 groups: rural, urban, and suburban. Then a random sample of each is analyzed. Is that simple, stratified, or systematic? That one would also be stratified. So I'm just going to move this down here, move that in there. So that one is stratified. Okay, so I'm just putting these in categories. Good. All right, so let's grab another one. So let's see. This one says, to test accuracy of a biometric scanner, a scientist uses a computer to generate a sample of 20 subjects from a population. That one is also going to be a simple random sample because, again, everybody, it's a random, they're just going to choose randomly with that computer. So every person in the population is as likely to be chosen as any other in the population. Okay? Let's grab another one. So from a batch of 22,000 smartphones, every 150th is tested. Which one would that be? That would be the systematic, because the sample is selected from a population according to this interval, according to a specific interval, okay, or item. All right, here's my last one. It says, to determine which passengers carry-on bags are to be inspected, every 8th person will check to have his or her bag. And again, this one is going to be systematic because it says every 8th person. So that one is systematic. And those are my examples. All right, so we're going to do the same thing with biased samples. So we want to know biased or unbiased, okay? It says a blank sample is obtained using a valid sample method that is random and representative of the population. This is an unbiased sample, okay? So this is unbiased over here. A biased sample is not representative of the population and usually favors one or more parts of the population over another. So this one is biased. Now, of biased and unbiased samples, we have convenience samples and we have voluntary response samples. So convenience samples, these include members of the population that are easily accessed. Okay, that's what convenience sample means. A voluntary response sample, that means that involves only those who want to or can participate in the sampling. So again, I'm going to pull out some examples and we're going to put them in the appropriate column. Okay? Is it a convenience sample or is it a voluntary sample? Is it? All right, so let's pull out the first one. It says, in order to find the favorite kind of music of seventh graders in the United States, a student takes a survey of her class. Is that convenience or is that voluntary response? All right, that one is going to be convenience because she's surveying her class, okay? And her class probably is the seventh graders. Got it? All right, let's pull out another one. A principal sends an email containing an online poll to graduating seniors asking where they prefer to hold graduation. The answers received are used to determine the location of the graduation. So this one is a voluntary. And the reason why is because the principal sends an email to all of the graduating seniors, and only the people who respond, who want to respond, who are volunteering to respond, are going to be part of that that sample. So this is going to be a voluntary response sample. All right, let's get another one. Okay, this says the manager of a retail store mails out a survey of 500 potential customers. She uses the results of surveys that are mailed back to determine which items to keep in stock for the spring season. Okay, again, that one is voluntary because the store manager mails out a whole bunch, and then only the people who choose to respond or send them back will be part of the survey. I mean, of the sample. All right, and let's do this last one. It says you survey a sample of 10 households on your street to determine how often households in the state cut their grass. Well, that one, of course, is convenience because you're sampling the households in your neighborhood. So that's going to be convenience. Does that make sense? Okay? All right. So there we have convenience and voluntary samples, voluntary response samples. All right, so now we're going to talk about valid inferences. It says, if you have used a valid sampling method and obtained an unbiased sample that is representative of the population, you can use the results to make inferences or predictions about the population. So you need to know what those two words, what that word means. So an inference is a prediction, okay, or a conclusion about the population, okay? Now, let's fill in these blanks. A blank, blank is biased on the collection of accurate and truthful data. So, a valid inference is based on the collection of accurate and truthful data. So let's write that down. This is a valid inference. Oops. And an invalid inference um, is based on uh, is a biased sample. It's based on a biased sample, and the data obtained may not be accurate or truthful about the population. So that is an invalid inference. So if we have a valid inference uses a valid sampling method, and the sample is drawn from an unbiased representative sample, unbiased representative sample, and it makes a conclusion that is supported by the data. An invalid inference may not use a valid sampling method, may not use a valid sampling method. I would here highlight may not use a valid sampling method. The sample is drawn from a biased or unrepresentative sample. So we're going to write biased or unrepresentative sample. Sample. And it makes a conclusion that is not supported by the data. Not supported by the data. Okay, so we're going to categorize again. We want to know which column. I'm going to pull out the examples. We're going to put it in the correct column. Identify the type of inference for each situation. Is it going to be valid or is it going to be invalid? Okay, so let's see. So 20 customers in a grocery store are randomly selected and surveyed about their juice preference. The results are shown in the table right here. After reviewing the data, the store manager decided that about half of the store's juice stock should be orange juice. So this sample is a random sample, and it is not biased, okay? So this is going to be a valid inference. So this goes in this column, valid inference. All right, let's take out the next one. It says, a quality control engineer for a technology company tests every 50th fitness tracker off the conveyor belt. She finds that 1 in 100 she tested did not meet the quality control standards. She infers that 1% of the fitness trackers made do not meet the standard. Is that valid or invalid? So, because it says that every 50th fitness tracker, this is a systematic random sample. So it is random, and it is not biased. So this is a valid inference. So her conclusion is valid. So that goes over here. Let's check this last one. All right. It says the customers in the music store one morning are surveyed to determine their favorite activity in their free time. The results are shown in the graph right here. The store manager concludes that most Americans either play music or listen to music in their free time. Well, of course, this is going to be an invalid inference because this is um, a convenience sample because all these people that they are surveying are coming into a music store on their free time, right? So what do you expect? They're going to like either playing or listening to music in their free time. So this one is in an invalid conclusion or an invalid inference. So that one goes in that column.